A black hole is a region in space where the gravitational pull is so immense that even light cannot escape. The gravity is so powerful because matter has been compressed into a minuscule area. This occurs when a star is reaching the end of its life. As no light can escape, black holes are invisible to the naked eye. Could black holes have interior lives that are more eventful than we previously thought? Could they explode? If an explosion is the sudden, brief release of tremendous amounts of energy, then the answer is a resounding yes. What's more, they can explode in several interesting ways, either by detonating themselves or by causing an explosion in their immediate vicinity. The explosion process is related to the fact that black holes are not entirely black. This was discovered by famed astrophysicist Stephen Hawking in 1976. Hawking found that with quantum mechanics, the hole slowly leaks away its energy to infinity by emitting low-energy radiation. This is called Hawking radiation. A black hole that isn't consuming new matter will gradually diminish over time as it emits Hawking radiation. However, this radiation is released slowly. For example, a black hole with a mass a few times that of the Sun emits around 1 photon, or packet of light, per year. Thus, it would take approximately 10 to the power of 100 years for the black hole to completely evaporate. But Hawking realized that smaller black holes evaporate at a much faster rate. As a black hole gets smaller, it emits more radiation. In the last moments of its life, the black hole emits so much radiation, so quickly, that it effectively acts like a bomb, releasing a torrent of high-energy radiation and particles. If small black holes, roughly the size of Earth, formed during the universe's infancy, they would take a few billion years to evaporate. Therefore, these primordial black holes, if they exist, would be detonating all over the place right now. Thus far, astronomers have not discovered any evidence of exploding primordial black holes, but they might exist. Rotating black holes create explosions that are unlike any other type of explosion found in the universe, and this is thanks to their spinning motion. Rotating black holes, which are also named curved black holes in honor of New Zealand mathematician Roy Kerr, who was the first to understand how they work, have an ergosphere surrounding their event horizon. An ergosphere is an elongated region of space where nothing can remain stationary. Any object or particle that falls toward the spinning black hole will begin to orbit around it as soon as it enters the ergosphere. The rotating spacetime around a black hole can also pull on photons. If there are enough photons, they can bounce off of each other or any wandering particles. Sometimes the bouncing reasons the photons to break out of the ergosphere. But in different instances, the bouncing motives the photons to fall deeper closer to the black hole, the place they attain energy. They can then get scattered to a greater orbit again, then fall return down. With every repeat of the process and every trip around the black hole, the photon features energy. This manner is known as superradiance. If the photon ultimately breaks free, it will have a widespread amount of energy in contrast to when it began its journey. If sufficient photons take part in the process, they can all come bursting out as soon as with exceptional energy, turning into what's recognized as a black hole bomb. Even though the black hole itself would not explode, this superradiant impact as soon as once more indicates simply how powerfully black holes can have an effect on their environment. The most frequent way that black holes reason explosions is not through their very own self-destruction, but via the sheer power of their overwhelming gravitational force. Supermassive black holes take a seat in the facilities of galaxies, and now and again giant clumps of matter, such as stars, bypass too close. When that happens, the star receives torn to shreds from tidal effects, and this tearing system releases an explosive burst of energy. Astronomers on Earth can witness this launch of strength as a short, however severe flare of X-ray and gamma radiation. Besides shredding up stars, those large black holes regularly gather swarms of be counted that continuously swirl round them in large accretion disks. The accretion disks attain temperatures of quadrillions of degrees, making them the brightest objects within the universe. A single sparkling disk can outshine over 1 million galaxies at once. At their maximum power, the disks land up electric and magnetic fields that funnel a part of the disk material from the black holes in the shape of long skinny jets that attain for tens of hundreds of light years.